So this is Unit 6 for chemistry. We're talking about chemical bonds. So in this unit, we're talking about chemical bonds, which generically speaking are a force that holds two atoms together. We've seen this definition in several units already. But today we're talking about a specific type of chemical bond, and that is a covalent bond. So in a covalent bond, two adjacent atoms will share valence electrons. Rather than gaining or losing, they're going to cooperate. So the atoms that share electrons become more stable because they're sharing. So the term covalent comes from the prefix CO, which means together, and the word valence. An important note here is that covalent bonds typically form between nonmetals. And in this class, it's pretty much exclusively nonmetals. The only exceptions you would really find out there, and they do exist, but the most common one that I think about is that there's a molecule in your blood cells called heme. It's part of hemoglobin, and it has iron in it. But in general, the things we use in this class, covalent bonds are between nonmetals. So a covalent bond forms when two or more atoms that are in close proximity begin to share electrons, with the purpose of achieving a more stable electron configuration. So each element is going to have a specific number of valence electrons, and the most stable configuration is a complete set of 8 valence electrons, which we've given a name before. It is a complete octet. And the interesting thing about a covalent bond is that each atom thinks that both of the shared electrons belong to itself. So they're trying to go for this noble gas configuration. Noble gases are stable, and they're stable because they have a complete octet. Covalent bonds allow atoms to get to the noble gas configuration, or that most stable configuration, by sharing the electrons. The representative particle, or the most basic unit of a covalent compound, is what we call a molecule. And molecule is a little bit overused because there are other types of compounds that do not have molecules. For instance, we talked about ionic compounds already, and the representative particle for an ionic compound is a formula unit. It is not a molecule. So a salt molecule would be an inaccurate statement. Oxygen is a good example of a covalent bond that makes two atoms more stable. Individual oxygen atoms are unstable, very unstable, because of their electron configuration. So I'm looking at my periodic table, and I see that oxygen is in group 16, which means it has 6 valence electrons. You could also say valence number of 6. That's the same thing as 6 valence electrons. To form a complete octet, each oxygen is going to need 2 more electrons. So what happens when 2 oxygen atoms are in close proximity? They're each going to share 2 of their electrons. And these electrons are going to form covalent bonds. So let's look back at something that we talked about a couple of units ago, and that is the electron dot structure. The electron dot structure shows me the valence electrons. So this is what one oxygen atom looks like, and it's unstable. But let's say that two come into pretty close proximity, and I'm going to draw them with their single electrons closer to each other. And so here's what's going to happen. They're in close proximity, they're both unstable, and so they decide that we're going to share this pair of electrons and we're going to share this pair of electrons. So if you look at the oxygen on the left, it only has 6 electrons of its own, but it thinks that this electron belongs to itself, and it thinks that this electron will belong to itself. So really, it thinks that it has 1, 2, 3, 4, 5, 6, 7, 8. So here's one oxygen, here's the other oxygen, and here's a covalent bond, which are these two shared electrons. And here's a second covalent bond, which is another 2 shared electrons. Now, each of these oxygens thinks that these two belong to itself, and these two. And then they have some that they're not sharing. So this oxygen on the left has 1, 2, 3, 4, 5, 6, 7, 8, just like it wants. It's sharing 4 and it's keeping 4 to itself. Same thing with the other one. 1, 2, 3, 4, 5, 6, 7, 8. So it's sharing some and it's not sharing others. So then we have a molecule. Once we have 2 or more atoms that start sharing electrons, we've formed a molecule. A molecule is a chemical compound created when atoms form covalent bonds. A molecule is typically made of nonmetals, which we already talked about most of the time. A molecule may be composed of 2 or more atoms, so it doesn't have to be just 2. Here's a specific type of molecule. It's called a diatomic molecule. It contains only 2 atoms, and they are the same element. A lot of nonmetals exist as diatomic molecules in their elemental form, like oxygen, because they're unstable. So as far as the diatomic molecules go, there are some mnemonics that you can find that will help you remember them. There's iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, and fluorine. These 7 elements will almost never exist as just one atom by itself. They are so unstable that they will find another atom of the same element and they will pair up. And so this is the elemental form when we talk about these 7 elements. So in a single covalent bond, each atom is contributing 1 electron, which means that the covalent bond is made from 1 pair of electrons. The shared pair of electrons forms the basis of the covalent bond. So let's talk about fluorine. And we've got 2 that are in close proximity. They're going to start sharing. So fluorine has 7 valence electrons. And so I'm going to draw it like this with the single electrons facing each other. And so what's going to happen is these 2 fluorines are very unstable and they are going to begin sharing these 2 electrons. And so we end up with 2 fluorines with a covalent bond. and then each fluorine has 6 electrons to itself that they are not sharing. And so this fluorine on the left thinks that it has 1, 2, 3, 4, 5, 6, 7, 8. And this fluorine on the right thinks that it has 1, 2, 3, 4, 5, 6, 7, 8. And so both of them are happy. They both think that they have a complete octet. But sometimes two atoms will share more than one pair of electrons. And when two atoms form a covalent bond, they may each contribute 2 electrons. The result is 2 electron pairs, or 2 pairs of 2 electrons. And when this happens, the result is a double bond. Double bond. And this is like the oxygen example that we already saw. So we had 2 oxygens. They are each sharing 2 electrons. And they both think that they have a complete octet. Interesting thing about a double bond is that, yes, it has 2 covalent bonds, but a double bond is not twice as strong as a single bond. It's not 2 times stronger. It's only about 1.5 times stronger. And so the double bond is referring to 2 electron pairs, not the strength of the covalent bonds. So it's possible that 2 atoms may contribute 3 electrons to a covalent bond. The result is 3 electron pairs, or 3 pairs of 2 electrons. The 3 electron pairs form a triple bond. Triple bonds are the strongest possible covalent bonds, and they are much stronger than a single bond. They are a little bit stronger than a double bond. But look at this. A triple bond is not 3 times stronger than a single bond. So for this one, we'll talk about nitrogen. And nitrogen has 5 valence electrons. So when we have 2 nitrogens that are in close proximity, they will start to share valence electrons. And so this one has 5 and it wants 3 more. This other one has 5 and it wants 3 more. So these 2 atoms will start sharing this pair. Now they both think that they have 6. They're going to start sharing this pair. Now they both think they have 7. And sharing this pair makes 8. And so when we redraw this, we have 2 nitrogen atoms held together by a triple covalent bond. And then each atom has 1 pair of electrons that it is not going to share. And when you count this up, you'll see that this nitrogen on the left has 1, 2, 3, 4, 5, 6, 7, 8. There's a complete octet. And the one on the right has 1, 2, 3, 4, 5, 6, 7, 8. It thinks it has a complete octet as well.